Hi, I'm Maggie. Today I will talk about effects of water temperature, age of feces, light intensity, and shelter on the consumption of sea urchin feces by the sea cucumber Apostichopus japonicus. This paper is from Journal of Aquaculture. What is integrated multi-trophic aquaculture, IMTA? IMTA is an effective method in which feces of one or more organisms are utilized by other cultural organisms from the different trophic levels. And the key of IMTA is that the nutritional recycling in aquaculture farms through the fecal consumption. Now I will introduce two important organisms in this system. The sea cucumber is a commercially important deposit feeder, and the sea urchin has high food and medicine value. The main purpose are to investigate whether sea cucumber ingests the feces of sea urchins at 5 degrees Celsius and 15 degrees Celsius, and the optimum aging hours for the fecal consumption by sea cucumber at 5 degrees Celsius and 15 degrees Celsius. Whether light intensity significantly affects the fecal consumption by sea cucumber at 5 degrees Celsius and 15 degrees Celsius. Whether shelter environment significantly improves the fecal consumption by sea cucumber at 5 degrees Celsius and 15 degrees Celsius. The present studies aims to evaluate and subsequently improve the fecal consumption in sea cucumbers. These juvenile sea cucumbers were weighted after draining. After they were weighted, they were cultured in 2 tanks at 5 degrees Celsius and 15 degrees Celsius. Under the photo period, 12 hours light and 12 hours dark. The seawater was changed every 3 days. To obtain the feces, the sea urchin were fed locally collected fresh kelp under the photo period. The perforated plastic nets allowed only the feces, but not the uningested kelp to fall to the bottom of the tanks. The feces was collected with a siphon. The experiment 1 chose tests to determine if sea cucumber ingests the feces of sea urchins. The experiment device was a plastic box which was divided into the side with feces and the side without feces. A sea cucumber was placed in the middle of the box for half an hour to investigate whether sea cucumber ingested the feces. Sea cucumber feeds through the grasping motion by the tentacle. The data were recorded using a digital recorder. Results and discussion of experiment 1. A and B diagram showing the staying time of sea cucumbers in the side with feces and the side without feces at 15 degrees Celsius and 5 degrees Celsius. C and D diagram showing the grasping time of the tentacles of sea cucumbers in the side with feces and the side without feces at 15 degrees Celsius and at 5 degrees Celsius. In the present study, sea cucumbers stayed significantly longer in the side with feces than the side without feces at both 15 and 5 degrees Celsius. Sea cucumbers show significantly more grasping time by the tentacles in the side with feces than the side without feces at both 15 and 5 degrees Celsius. The present result further indicates that the feces not only has great potential to be an alternative diet for sea cucumbers at the optimum feeding temperature, but has the potential to solve the problem of ceasing feeding in sea cucumbers in winter. Experiment 2. Effects of the age of feces on fecal consumption by sea cucumbers. The age of the species was variable, including 0 hour, 24 hour, 48 hour, 72 hour, and 96 hour. The number of fecal particles was recorded by photographing and was then calculated using software before and after the experiment. The result and discussion of experiment 2. A and B diagram showing the number of fecal particles consumed by sea cucumbers. FPC at 15 degrees Celsius and at 5 degrees Celsius. C and D diagram showing the excreta weight of sea cucumbers, EW, at 15 degrees Celsius and 5 degrees Celsius. At 15 degrees Celsius, there was no significant difference in the FPC and EW of sea cucumbers among 0 hour, 24 hour, 40 hour groups. This indicates that the optimum aging hours of feces are 0 to 48 hours at 15 degrees Celsius, which is consistent with a temporal peak in microbial activity for feces of various aquatic animals. At 5 degrees Celsius, there was no significant difference of FPC and EW in sea cucumber among 0 hour, 24 hour, 48 hour, and 70 hour groups. It suggests the optimal aging hours are 0 to 72 hours at 5 degrees Celsius, which is longer than the optimal aging hours at 15 degrees Celsius than at 15 degrees Celsius. An explanation is that feces decay faster at 15 degrees Celsius than decays faster at 15 degrees Celsius than at 5 degrees Celsius, since microbial degradation of feces differs at different water temperature. Consider the importance of food consumption to the growth of sea cucumbers. We suggest aquafarmers not feed them with overrich feces and remove the feces in time. Experiment 3. Effects of light intensity on the fecal consumption by sea cucumbers. Two treatments were set as high light intensity and low light intensity to observe the effects of light intensities on the fecal consumption by sea cucumbers at both 5 and 15 degrees Celsius. Result and discussion of experiment 3. A and B diagram showing the number of FPC by sea cucumber at 15 degrees Celsius and at 5 degrees Celsius in the light intensity experiment. C and D diagram showing the EW of sea cucumber at 15 degrees Celsius and at 5 degrees Celsius in the light intensity experiment. Sea cucumber exposed to low light intensity show significantly bigger FPC than individual of the high light groups at both 15 and 5 degrees Celsius. However, no significant difference of EW was found between the low light intensity group and high light intensity group at 15 degrees Celsius. Sea cucumber has exposed to low light intensity had significantly higher EW than those in high light intensity at 5 degrees Celsius. This suggests the feeding benefit of low light intensity is widespread at various temperatures and provides valuable information into the application of sea urchin feces in the sea cucumber aquaculture in winter. Experiment 4. Effects of shelter on the fecal consumption by sea cucumbers. We set the shelter group and the control groups to investigate the effects of shelter on the fecal consumption by sea cucumber. Result and discussion of experiment 4. A and B diagram showing the number of FPC by sea cucumber at 15 degrees Celsius and at 5 degrees Celsius in the shelter experiment. C and D diagram showing the EW of sea cucumber at 15 degrees Celsius and at 5 degrees Celsius in the shelter experiment. Sea cucumber of the shelter group show significantly bigger FPC That individual of the control groups and significantly higher EW of sea cucumbers than that in the control groups at 15 degrees Celsius. Sea cucumber of the shelter group show significantly bigger FPC than those of the control groups at 5 degrees Celsius. However, EW of shelter group had no significant difference to that of the control groups. So, sea cucumber ingests the feces of sea urchins at 5 degrees Celsius and 15 degrees Celsius. The optimum aging hours for the fecal consumption by sea cucumber at 5 degrees Celsius are 0 to 70 hours, and at 15 degrees Celsius are 0 to 48 hours. Light intensity significant affects the fecal consumption by sea cucumber at 5 degrees Celsius and 15 degrees Celsius. Shelter environment significantly improve the fecal consumption by sea cucumber at 5 degrees Celsius and 15 degrees Celsius. The present studies provide valuable information in evaluating and improving consumption of sea urchin feces by sea cucumber in the IMTA of sea cucumber and sea urchin. Thank you.
Hi, I'm Daphne. Can you explain what is photo period?
She wants to ask what is photo period.
Yes.
I didn't Google. I just know that they put the cucumbers in 12 hours light and 12 hours dark.
Okay, thank you.
Hi, I'm Tina. Can you interpret why choose the temperature at 5 and 15?
She wants to ask why choose 5 degree and 15 degree.
Yeah.
I think it's because one is higher temperature and one is lower temperature because they didn't mention.
Okay.
I can help you answer the question that Tina asked. It actually has explained why they choose 5 degree and 15 degree in the introduction of this paper. So that's the answer for Tina can find it. And my question is about, can you go back to the experiment, the material? I wonder how they can get the fecal they use.
They use a siphon to collect the fecal.
So if they have the same density they use for the experiments later,
I think they put at anywhere they want.
Oh, thank you for your question.
Hi, I want to ask in experience 1, how they define the grasping time or stating time.
The grasping times, they use a digital recorder to record the grasping times, and the same times, I think they were just record by phones.
Thank you.
I think Maggie, she chose a very easy to present paper, because I think that was a good choice, because in this paper there were many figures. So these figures were all in the paper. That was really nice. And but this one was not, so you made it yourself, I guess. But overall, and the plots are easy to, the graphs are easy to understand. So it's a good choice. And she also made very nice presentation. Like you see, the introduction slides was easy to understand and rich in images. So you know immediately what the study was about. So that was a very good choice. Then regarding the parts to be improved, I think the first thing is you have actually 2 purpose slides. This one should be displayed first, because this is the overall purpose. Then you talk about the special conditions that is related to your 4 experiments. So this one should be displayed first. And then from time to time, you have some difficult terms. For example, like kelp. Okay, so what is kelp? And for example, you have things like words like I don't remember where they are. For example, like this one, like is excreta weight. Okay, and at some point you start to use these 2 abbreviations, FPCEW. However, considering that your talk is a rather straightforward talk, I mean the content is straightforward, I would suggest that you don't really need to use this abbreviation. You can just say, okay, you say the full words, but you can maybe make it easy, like the fecal particle number, for example, excreta weight, but you need to explain what is excreta. And then I also suggest that although you did a nice work by showing the experimental design, and then you show the result immediately. That was really good. But I think sometimes you can, for example, here you show the experimental design, like this one, then you can maybe show this image again on top here, make it smaller, so it's easier to relate your result to your experiments. And then I think for your 4 experiments, 3 of them you did not add concluding remark, except experiment 2, where you have this concluding remark, this sentence. Okay, this kind of sentence is helpful for the audience. You can orient them to your main finding. But this was the case for this slide. However, for many other slides, you were drawing conclusion. You said a lot. You were like blah, 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 blah. But there was actually no words here, so we don't really know what to look at. So it would be always helpful to add a short concluding remark like this one. Okay, and then it is a good choice that you reuse your the purpose slide was used at the end as the conclusion. This one, but I think you can change the header, like our main finding are. Okay, so remember to change the header, but it's a good choice that so there's a sense of coherence in your talk. And then at the end, next time, I hope you can look at the audience instead of your mobile phone. And another thing is you can talk with some up and down in your tone. Because when you were reading, you were like, the present study provides valuable information evaluating improving consumption of sea urchin feces by sea cucumber. Okay, you can slow down and with a little bit up and down, so we know what is the key point. Okay, but overall it's a good talk. So let's thank Maggie.